Dear children, welcome to today's class. Today we begin a new lesson, carbon and its compounds. Carbon is the fourth most abundant element in the universe after hydrogen, helium and oxygen. It is a non-metal and it exists in free as well as in combined state in nature. Carbon is found in free state in the form of diamond, graphite and coal. Carbon is tetravalent and has a unique property of forming chains by self-linkage. Atoms of carbon can link together by covalent bonds to form long chain molecules. This property is called catenation. Let us define catenation. The property of self-linking of an atom of an element through covalent bonds in order to form long chain molecules is known as catenation. It is the self-linking property of an atom of an element through covalent bonds and forms long chain molecules. Carbon shows the property of catenation. It is because of this property that carbon alone forms more compounds than all the other elements put together. All complex molecules found in living organisms such as blood, hormones, proteins, RNA, DNA and enzymes contain carbon. So large is this number and that a branch of chemistry called organic chemistry studies carbon and its compounds. So, there is a branch of chemistry known as organic chemistry which deals with the study of carbon compounds. Carbon forms millions of compounds due to the property known as catenation. So, in order to study these carbon compounds, we have a special branch in chemistry known as organic chemistry. Organic chemistry deals with the study of carbon compounds. As said earlier, carbon is found in free state in the form of diamond, graphite and coal. So these are the different forms of carbon. These different forms are known as allotropes and the phenomenon is known as allotropy. So let us define allotropy. Allotropy is the existence of an element in two or more forms in the same physical state. An element exists in two or more forms in the same physical state. These different forms of elements are known as allotropes. These different forms of elements have different physical properties but they have same chemical properties. So, we can define allotropy as it is the existence of an element in two or more forms in the same physical state having different physical properties but same chemical properties. The different forms of an element are known as allotropes. We know that carbon shows allotropy. Let us study the allotropes of carbon. That means carbon can exist in different forms in the same physical state with different physical properties but same chemical properties. Let us see the allotropes of carbon. Allotropes of carbon are classified into two categories, which are the crystalline allotropes and amorphous allotropes. Allotropes of carbon are classified into two categories, crystalline allotropes and amorphous allotropes. The crystalline forms of carbon are graphite, diamond and fullerenes. Which are the crystalline allotropes of carbon? graphite, diamond and fullerenes. Amorphous forms of carbon are coal, charcoal, lamp black, gas carbon and coke. Crystalline allotropes of carbon, they will have a definite crystalline shape, geometrical shape. Amorphous forms, they do not have any definite geometrical shape. Let us study the difference between crystalline forms and amorphous forms. Crystalline forms, they have a regular arrangement over a long range. Amorphous forms, they have a regular arrangement over a short range. Then they have definite geometrical forms. Crystalline forms of allotropes have definite geometrical forms, sharp edges and plane surfaces. These forms are referred to as crystal. A crystal is a solid with a definite geometrical shape. Amorphous forms do not have definite geometrical forms, sharp edges and plane surfaces. Then crystalline forms have sharp melting points. Amorphous forms do not have sharp melting points. They melt over a range of temperatures. Crystalline forms have high melting and boiling points. Amorphous forms have low melting and boiling points. Example for crystalline allotropes: diamond, graphite and fullerenes. Diamond, graphite and fullerenes are crystalline forms of carbon. Charcoal, coal, lamp black, gas carbon and coke are the amorphous forms of carbon. So, here the main point of difference is that crystalline forms of allotropes, they have a definite geometrical shape. Amorphous forms do not have a definite geometrical shape. Crystalline forms have high melting and boiling points. Amorphous forms have low melting and boiling points. Now let us study the crystalline forms of carbon. First we have diamond. Diamond is the hardest naturally occurring substance. All of you know that. Diamond is the hardest naturally occurring substance. It is colorless, lustrous and transparent. Its density is 3.5 gram per cubic centimeter. The brilliance and beauty of a diamond depends on its cutting and polishing. It is a good conductor of heat but a bad conductor of electricity. It burns at 850 degrees Celsius to 1000 degrees Celsius in air to form carbon dioxide. In diamond, each carbon atom is linked with 4 other carbon atoms in a tetrahedral shape. You know, diamond consists of carbon atoms, and in diamond, each carbon atom is linked with 4 other carbon atoms in a tetrahedral shape. Next one is graphite. Graphite is soft, greyish black and lustrous solid. It is a good conductor of heat and electricity. Graphite is the non-metal that contains electricity. Let us see the structure of graphite. In graphite, each carbon atom is linked with 3 other carbon atoms forming a flat or layered hexagonal unit. This basic unit repeats itself and forms a layered network. There is a weak force of attraction between the layers. So we know that diamond and graphite are the crystalline forms of carbon. Even though they contain carbon atoms, they are the allotropes. Physically, they are different. Chemically, they show same chemical properties, but physically they are different. Let us study the differences between graphite and diamond. Let us go through the table. Diamond, it is colorless and transparent. Graphite is grayish black in color and shiny and opaque in appearance. You know what is a transparent object? What is an opaque object? A transparent object is a one which allows the passage of light. An opaque object does not allow the passage of light. So diamond is transparent, on the other hand graphite is opaque. Diamond is colorless, graphite is grayish black in color. Diamond does not leave a mark on paper. Graphite, on applied pressure, it leaves a black or grey mark on paper. This is the reason why graphite is used in your pencil lead. Graphite mixed with the clay is used in pencil lead because graphite leaves a black mark on paper. Then diamond is hard to touch. It is the hardest natural substance known. On the other hand, graphite is soft and greasy to touch. Diamond has a tetrahedral structure. Graphite has a hexagonal layered structure. Then the next property, diamond is a bad conductor of electricity and a good conductor of heat. On the other hand, graphite is a good conductor of heat and electricity. Then let us see the density. The density of diamond is 3.5 gram per cubic centimeter. Graphite has lower density, that is 2.25 gram per cubic centimeter. Diamond burns in air at 900 degrees Celsius to produce carbon dioxide. Graphite burns in air at 700 degrees Celsius to produce carbon dioxide. So let us see the main points of differences between graphite and diamond. First point, diamond is colorless and transparent. Graphite is grayish black and opaque. Diamond does not leave a mark on paper. Graphite leaves a black mark on paper. Diamond is the hardest naturally occurring substance. That means it's very hard. Graphite is soft. Diamond has a tetrahedral structure. Graphite has a hexagonal structure. Tetra means 4. Hexa means 6. Diamond is a bad conductor of electricity. Graphite is a good conductor of electricity. Diamond has high density 3.5 gram per cubic centimeter. Graphite has low density 2.5 gram per cubic centimeter. I hope you understood. Today we learnt about allotropy, allotropes of carbon, crystalline allotropes of carbon, amorphous allotropes of carbon. I hope you understood the topic. Let us wind up for the day. Thank you.